Good day and welcome to School of Chemistry. This is your first time in this channel. Please click on the subscribe button and turn on the notification bell so that you get updates. We'll be dealing with the concept of the mole. And today we'll be looking at just the introductory aspect, understanding the concept of the mole. What exactly does the word mole mean, and outside the extract definition? So let's begin. Now, in real life, we have certain standards in which we relate to things. For example, if I say a dozen, we all know we're talking about 12. If it's a dozen of books, a dozen of pencil, a dozen of even human being, a dozen of eggs, whatever you have, it doesn't represent 12. Also, when we talk about a pair, we know we are talking about two. A pair of shoes, a pair of socks, a pair or whatever you want to talk about. But a pair, we know everywhere a pair is two of that thing. So also the concept of a mole is a standard that represents a large number. For example, if I ask you to tell me the number of molecules the number of molecules in this glass of water, you find it so difficult to count. So these are the kind of things we're trying to look at. In chemistry, we deal with molecules we can see. They are too minute, but they react in certain proportions. Such proportion has very little to do with mass, since every molecule have a different mass. For example, the mass of hydrogen is 1, while the mass of carbon is 12, the mass of fluorine is 19. So see that every molecule have different mass, and therefore you cannot use mass as a standard. On that note, such proportion has nothing to do with mass, since every molecule have a different mass. Rather, they react by numbers as seen in balance equations. For example, when tetraoxosulfate 6 acid reacts with sodium hydroxide, to form disodium tetraoxosulfate 6 acid and water. So you see that instead of reacting, they are reacting in numbers. One of these is reacting with two of these to form one of these and two of these. I say one of tetraoxosulfate 6 acid is reacting with 2 of sodium hydroxide to form 1 of sodium sulfate and 2 of water. So in chemistry, we talk about molecules numerically, and that number has to be so big that it represents a number of molecules we can see with our eyes, and that number is the mole. The number, a figure that represents the number of molecules that is big enough for us to see with our eyes, is what we're trying to study, and we call that concept the mole. The mole is just a number, like I said, like a pair, a dozen, a carton, a crate, a bundle. It is a very huge number, which is equals to the Avogadro's number. And Avogadro's number. And this number is equals to 6.022 multiplied by 10 raised to power of 23. And what is this number? This number is simply the number of carbon atoms in exactly 12 grams of carbon 12. So when you weigh 12 grams of carbon 12, the number of molecules you see there is 6.022 times 10 raised to power 23. So if you take 2 moles of carbon 12, the molecules you see there will be 2 times 6.0. So 1 mole of any substance is equals to 6.022 times 10 raised to power 23 atoms, molecules, or particles. 2 moles will be equals to 2 times 6.022 times 10 raised to power 23 atoms, molecules, or particles. So when we are talking about the mole, we are talking about a standard figure that represents the number of particles in 12 grams of carbon 12. So the mole of any substance scientifically can be defined as the amount of that substance that contains as many elementary entities as there are in exactly 12 grams of carbon 12. The mole is the amount of substance that contains as many elementary entities as there are in exactly 12 grams of carbon. Carbon 12. That is the mole. The mole is the amount of substance that contains as many elementary entities as they are in exactly 12 grams of carbon 12.